Let's review the 68, 95, 99.7 rule because this relates right to a normal distribution. So for example, IQ scores are normalized with a mean of 100 and standard deviation of 15. And one thing I'd recommend doing is if you recognize that maybe answer choices talk about 68, 95, or 99.7, which relates to 1, 2, and 3 standard deviations above and below the mean. That also relates to a z-score of 1, 2, and 3, or -1, -2, and -3 for above and below the mean, respectively. Regardless, what I recommend doing is, given the time, I would just go ahead and put right down the middle your mean is 100. I would add 15 3 times, and I would subtract 15 3 times to get that overall 68, 95, 99.7 rule. Because if you do that, then these questions will be a little bit faster. What is the probability that someone has an IQ over 130? So 130 is 1, 2 standard deviations away from the mean. The middle, 95%, would relate to 2 standard deviations above and below the mean. Well, in this case, I don't want 95%. I want what's over here. And if 95% is in the middle, that is 5% left over, or 2.5% on each side. And that is the answer for part A. What is the probability someone has an IQ over 130? So the answer there, let's get rid of that little piece right there, boom, 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 is going to be 2.5%. What is the probability someone has an IQ between 85 and 115? Well, that would be 1 above and 1 below. That'd be the same thing as saying a z-score of 1 and a z-score of -1. If you're 1 above and 1 below, that is the middle, 68%, which is the answer for part B. The lower 2.5% of people have what IQ score? Well, if there's 2.5% below, then there's got to be 2.5% above, giving you 95% in the middle. And I marked that because I knew it would relate to 2 standard deviations above and below the mean. Again, equivalent to saying the z-score of 2 and -2 would have 95% in the middle and then 2.5% on each side. So in this case, the lower 2.5% would cut off at an IQ score of 70. But before I do that, let's keep that. Let's keep that. You know why? Do you know why? Because the last question, what is the probability someone has an IQ of exactly 151? It doesn't matter if it's way over here. The problem is there's no shaded region. Okay, all these were over 130, between, lower 2.5%. Exactly, you can't. For continuous distributions, you can't pinpoint an exact value. So in that case, the probability would be 0%, 0%, 0.000.